Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and hello. Today our group will present the topic of stack. Our group member is Muhammad Amir Syafiq, Hasif, Ahmad Syazriani and also Nurul Aisyah. Okay, introduction of stack. A stack is a linear list in which all insertion and deletions are restricted to one end, called top. It is a temporary abstract data type and the data structure based on the principle of last in and first out, LIFO. A frequently used metaphor is the idea of stack of book. In such a stack, only the top book is visible and accessible to the user. All other books remain hidden. Okay, here is the example or the diagram for stack. When we push, if A, B, C are pushed into a stack, okay, we push A, B, C, the child C will be on the top, and the B and A will be remain hidden like a book. Okay, here is an example of push the data into stack. Then we push 1, we push 2. Now 2 is the top of the stack, and then we push 3, and now top is 3. And then we do the operation of pop. Pop is deleting the data. We pop 3, we pop 2, we pop 1, and then the stack will be empty. And if we do the next pop operation, then it will pop up the underflow message. Okay, the operation is stack. We have 3 operations, which are push operation, pop, and also top. Push operation is inserting data. Push operation is to add or insert item at the top of the stack. The new item become the tops. The only problem with this operation is to ensure there is a room for the new item. If not, the stack will be overflow and the item cannot be added. So we must check somehow the stack is full or not yet. Pop operation is deleting data. Pop operation is to remove the item at the top of the stack. Because the top item is removed, the next item in the stack become the top. When the last item in the stack is deleted, the stack must be set to its empty state. If pop is called when the stack is empty, then it is pop up the underflow message. Okay, top operation, which is top operation is operation that returns the data in the top element. When we do this operation, then it will return the top element. Top can be underflow state when the stack is empty. It cannot be returned any data because the stack is empty. When these items are pushed and then pop, the result is that all items are in reverse order. Okay, let's go to the next topic that will be presented by Amirul is stack implementation. Thank you.
Assalamualaikum and hi everybody. I'm Amirul, so let's continue on stack implementation. I will explain it very quickly because we have many things in application. So implementation divides by 2, which is in array and linked list. First, stack in array. For stack and an array, the number of element in stack is fixed, which is 0. The initial position, which is 0, will always be the top. See the ring below, top. When we add an item, the top is increased, and we pop out the item, the top is decreased. Same goes for here. Remember that when array stack is 0, which is underflow, top will always be index -1. So in C++, top return the data in top element of the stack. Member variables are the array and top. So before push method can be done, a test net to carry out to ensure that the stack is not full. If it's full, the message flow will be print out. Same goes to the pop. A test net to carry out to ensure that the stack is not empty. So next is stack as a linked list. Stack in array is much easier because number is fixed. But the problem is when stack size is unknown, it's because the stack is to be overflowed. So we use stack linked list that have pointers as long as our computer memory is not full. Stack using pointers in structure to represent a node that contains data, and the next pointer to the next node in the stack. A top pointer is created to point to the top node, and constructor initialize top equal to null. So next is stack application, and thank you.
Assalamualaikum and very good afternoon. Thank you Amirul for presenting this stack implementation. So for today, I'm going to present stack application binary conversion. So for example, convert 104 base 10 to binary. So the first one in this application, we have the value of 104 divided by 2. We will get the answer and the remainder. So the remainder will be pushed into the stack array, and after that it will repeat the process. So 52 will be divided by 2 and get another answer, and get the remainder will be pushed to stack array and repeat again, and finally we get this. Then all the remainder from the stack array will be popped out and we'll get the answer. So that's it for stack application binary conversion. Up next will be another application. It will be presented by Aisha.
Hello, my name is Nurul Aisha and I'm going to present about the subtopic parenthesis matching. So firstly, stack can be used to check parenthesis matching in an equation using last in first out principle. So looking at the first expression here, we can see that a right parenthesis is missing. Therefore, the program will conclude it as not a match. On the second expression here, we can see that the left parenthesis is matched with the right parenthesis. So the program will conclude it as a match. Next, we will see how the stack implementation is implemented in parenthesis matching. So first, the program will scan the expression from left to right. Then, when the left parenthesis is encountered, it will add its position or parenthesis to the stack using push operation. And when a right parenthesis is encountered, the program will remove the matching position or matching parenthesis from the stack using pop operation. For example, this given expression. So for each left parenthesis, the program will push the left parenthesis character into the stack. And for each right parenthesis found in the expression, it will pop one left parenthesis from the stack. So we can see that the first left and right parenthesis is a match, which is this left parenthesis and this right parenthesis. And then next, the second left and right parenthesis is also a match, which is this left parenthesis and this right parenthesis. Then the program will encounter a right parenthesis. So for the third right parenthesis, there is no more left parenthesis left in the stack. Therefore, the program will conclude it as not a match. So regarding parenthesis is not a match, it is if at the end of the equation, every left parenthesis and also the right parenthesis is already been matched. Also, we need to take into account that if there is still one left parenthesis in stack, and also if there is still a right parenthesis but the stack is already empty, this also means that it is not a match. Lastly, we will go into the parenthesis matching algorithm. From the pseudocode here, we can see that step 1, we need to create a stack, and then the second step is to set variable continue with a true value and create a while loop. A while loop that will loop until the end of the input, and also as long as the variable continue is true. So inside the while loop, we will read the character from the equation, and then if the character is the left parenthesis, the program will push the character into the stack. Else, the program will check if the stack is empty. If the stack is empty, it will set the continue variable as false. Else, it will pop the stack if it finds a right parenthesis. So outside the loop, if it has reached at the end of the input and also the input is empty, so outside the loop, if it has reached the end of the input and also if the stack is empty, then print out balance, else print out not balanced.